Welcome to Quick Horse Digest. Today, we're going to pull back the curtain on the hidden brain that runs, well, pretty much everything. We're talking about the Programmable Logic Controller, or as most people call it, the PLC. So, have you ever stopped to wonder how it all works? I mean, really works. That baggage system that magically gets your suitcase to the right plane, or the climate control in a massive skyscraper. There's an invisible force making it all happen, and spoiler alert, it's almost always a PLC.
You know, to really appreciate just how brilliant the PLC is, we need to take a quick trip back in time, back to a world before software, to what we could call the age of relays.
Before PLCs came along, automation was a physical, mechanical beast. I want you to imagine these giant metal cabinets, just jam-packed with thousands of clicking electromagnetic switches called relays. They were all physically wired together to create logic. So if this switch is on and that switch is on, then click, this other switch flips.
Honestly, these systems were a total nightmare. They were enormous, they guzzled electricity, and they got super hot. But you know what the biggest headache was? They were completely inflexible. If you needed to change the process, you had to call in an electrician to physically unwire and then rewire that whole rat's nest of connections. And if just one of those thousands of relays failed, good luck. Finding it was like a frustrating, super time-consuming treasure hunt.
So yeah, industry was desperate for something better, something smaller, more flexible, and way more reliable. And that is exactly what they got.
And here it is, the PLC. The best way to think about it is as a special-purpose, super tough computer. I mean, this thing is built like a tank to survive the heat, dust, and vibrations of a factory. It doesn't have a screen or a keyboard or a mouse. It has one job and one job only. Run a program that controls a machine.
And the difference was, well, it was revolutionary. That tangled mess of physical wires was replaced by a simple software program. Now, if you wanted to change how a machine worked, you didn't need a wire stripper. You just needed to upload some new code. Those massive control panels got replaced by these compact little boxes that barely used any power. It was a game changer.
So, how does this little box actually think? Well, it all boils down to a super simple, incredibly fast, and repetitive loop. It's called the scan cycle.
A PLC is really made of just three key parts. You've got the CPU, which is the brain of the whole operation. Then you've got input modules. Think of these as the PLC's senses, its eyes and ears. They get signals from the real world, like a button push or a sensor spotting something. And finally, you have the output modules. These are the PLC's hands. They send signals out to do stuff, like turn on a motor or open a valve.
Now, the PLC runs through this little four-step dance thousands of times per second. It's a constant loop. First, it looks at all the inputs. What's going on out there? Then it runs the program, applying its logic to what it just saw. Based on that, it makes a decision. And finally, it updates all the outputs, telling the real world what to do. This whole thing happens in just a few milliseconds, over and over and over.
Okay, so that's the theory, but let's see how this super simple idea gets built up to create the kind of incredible automation that we see all around us.
Let's go back to that airport. You've just checked your bag, it gets that little sticky tag, and poof, it disappears onto a conveyor belt. From that moment on, a PLC is in charge of its destiny.
A sensor, one of the PLC's eyes, sees your bag coming. A little red light flashes, and beep, it scans the barcode. That's the input. All the data about where your bag needs to go is now inside the PLC's brain. Instantly, the CPU runs its program. The logic is dead simple. If the barcode says this bag is going international, then it needs to go to route A. If it says domestic, then it needs to go to route B.
And once that decision is made, the PLC flexes its muscles. It sends a signal out to one of its hands, a physical diverter arm on the conveyor belt, which pushes your bag onto the correct path. It's fast, it's accurate, and it does this thousands of times an hour without a single complaint.
Okay, so that's a pretty straightforward if this, then that kind of decision. But here's where it gets really cool. The true power of a PLC is its ability to layer multiple conditions to make genuinely smart choices.
So take a smart boiler system. A really basic system just has rule 1. If the thermostat says it's cold, turn on the boiler. Simple. But a PLC can add rule 2. Okay, it's cold, but let me check the time. Is it 3 a.m. on a Saturday? Well, the building is empty, so let's save some energy and keep the heat off. And then it can add rule 3. Let's check a motion sensor. So the schedule might say people are here,
But if the sensor sees nobody's actually moving around in that room, the PLC can override the schedule and keep the boiler off. See? That's the power of programmability.
And when you start to see that, you understand why this technology completely took over modern industry. It wasn't just a small step up, it was a total paradigm shift.
The advantages are just huge. They are incredibly flexible. You can reprogram them for a totally new job in minutes. They're reliable because solid-state electronics just don't wear out like old mechanical switches. They are lightning fast. You can easily scale a system up by just adding more input or output modules. And maybe best of all, if something does go wrong, troubleshooting is 1,000 times easier. You just plug in a laptop and the software can literally show you where the problem is. So from the traffic lights on your way to work, to the elevator in your office, to the assembly line that built your car, these humble, rugged little boxes are the unsung heroes of our automated world. The next time you see any complex process just running smoothly and perfectly, there's a really good chance you'll know the secret. There's a little PLC brain in there making it all work.